Now let us go through the properties of a conjugate of a complex number. So here is a list of the typical properties which are frequently used. First is conjugate of a number z is equal to the original number z itself, which is evident from the definition of the conjugate. The second one is z plus z bar is equal to 2 times the real part of z. Now here also if we add a number and its conjugate, then the imaginary parts will get cancelled, so therefore we are left with 2 times the real part. Similarly, in the third one, if we have z minus z bar, here the real parts will get cancelled, therefore the answer will be 2i times the imaginary part of the number z. Now next, fourth property is saying that if z is equal to z bar, then z is purely real. That means if a complex number is equal to its conjugate, then it means it does not have any imaginary part. That means the z is purely real number. Now fifth one, z plus z bar equal to 0, it means z is purely imaginary. Or if we have z is equal to minus of z bar, then it means z is purely imaginary because it won't have any real part in that. Sixth one is a very important property. It says z into z bar is equal to mod z the whole square. Now here we know that if we consider z as say x plus iy, then we have x plus iy into x minus iy, as we have here the product of a number and its conjugate. So this equals x square plus y square, because minus I square will be equal to plus 1, and x square plus y square is nothing but the square of the modulus of that complex number. So therefore we have this particular property. Now next one is property number 7, which says z1 into z2 bar plus z1 bar into z2 is equal to 2 times the real part of z1 into z2 bar, and it is also equal to 2 times the real part of z1 bar into z2. Now all of these properties can be easily proven by taking z1 and z2 as a1 plus ib1 and a2 plus ib2 respectively, and on substitution we will be able to prove these properties. Now let's move ahead and see a couple of more properties. Now if we compare 8, 9, 10 and 11, they give us the property related with the conjugate of addition, subtraction, multiplication and division of two complex numbers, and it is straightforward. That is, the conjugate of addition is nothing but addition of conjugates, which is property number 8. And similarly, in the 9th we have the conjugate of subtraction is the conjugate of z1 minus conjugate of z2. So here we subtract the two conjugates. In the 10th we have the conjugate of product z1 z2 is equal to the product of two conjugates, that is z1 bar to z2 bar. And similarly in the 11th, if we have the conjugate of division of two numbers z1 and z2, then that is equal to the division of two conjugates, that is z1 bar upon z2 bar, assuming that the denominator z2 is not 0. Now in the 12th one we have z bar raised to n is same as the conjugate of z raised to n. That is, whether we take the conjugate first and raise it to the power n is same as raising it to the power n and then taking the conjugate. And lastly, the 13th property says that if w is some function of a complex number, say z, then the conjugate of w will be equal to the function of conjugate of z. So that means if we replace z with z bar in the function, then the value of that function will also get replaced with its conjugate, that is w bar. Now let's solve a few examples based on the conjugate. Now here in this question, if the conjugate of x plus iy into 1 minus 2i is 1 plus i, then we have to decide which of the following 4 options is the correct answer. Now here what we are given is the conjugate of this particular product, that is this is equal to 1 plus I. Now we know that by the property of conjugates we can break these two, that is conjugate of x plus iy into conjugate of 1 minus 2i is equal to 1 plus I. So conjugate of x plus iy is nothing but x minus iy, and conjugate of 1 minus 2i is nothing but 1 plus 2i, that is equal to 1 plus I. So that gives us x minus iy is equal to 1 plus I upon 1 plus 2i. Now here we see that x minus iy is given as one of the options, but there the numerator is 1 minus I, whereas we have got it as 1 plus I. So that means we have to try the other possibility, that is x plus iy. That is, now here we take the conjugate of both sides, that is conjugate of x minus iy must be equal to conjugate of 1 plus I upon 1 plus 2i. Now by the property of conjugates, this is equal to the conjugate of 1 plus I whole divided by the conjugate of 1 plus 2i, which is equal to 1 minus I upon 1 minus 2i, and conjugate of x minus iy is nothing but x plus iy. So therefore we get x plus iy to be equal to 1 minus I upon 1 minus 2i. So therefore answer C is the correct option. Now let's go ahead and see another sum. We have to find the reciprocal of 3 plus root 7i. So that means if we consider this number as z, so we have to find the reciprocal, that is 1 upon 3 plus root 7 times I. Now here we know that if the denominator is not purely real, then we have to first make it as purely real by multiplying and dividing by the conjugate of the denominator. So therefore we multiply and divide by the conjugate, which is 3 minus root 7i. So therefore in the numerator we have 3 minus root 7 times I, and in the denominator we have 3 square, which is 9, and plus we have root 7 square, which is 7. So therefore we have 3 minus root 7i upon 16. So just separating real and imaginary parts, we have 3 by 16 minus root 7 by 16 times I. So that's the answer of this particular question.